Hello class, I'm going to do a short correc number 6 Zoom video for simplifying fractions. Um, and in the future, if remember there is a YouTube, there's usually a list of YouTube videos that you can watch also in addition to the supplementary Zoom video. And I do have like some saved past notes also that you can always make use of. And so just keep that in mind, okay? Um, so we'll start off by saying that when we simplify fractions to lowest terms, that a fraction is said to be in lowest terms if the numerator and denominator share no common factors other than 1. Okay, and so we have a few examples on the next page to show you here. This is in your COREC workbook. So here they're asking you to simplify these fractions to lowest terms. So we have 6 over 10. Notice how both 6 and 10 are considered even numbers. And the reason why we call a number even is because usually even numbers end in either a 0, a 2, a 4, a 6, or an 8. And so when I see 6 and 10, I see that, ends in a 6 or a 0. These are even numbers. And even numbers typically can be reduced by 2. Okay, so even numbers end in 0, 2, 4, 6, or 8, and are divisible by 2. And what divisible means is that, when we divide by 2, when we divide, we end up with a remainder of 0. So 6 over 10, to show your work, show your teacher that you're going to reduce by 2, common divisor, and 6 divided by 2, you can show that in your calculator. 6 divided by 2 is 3, and 10 divided by 2. 10 divided by 2 is 5. Okay, so notice that when you're reducing a fraction and you're trying to find a common a greatest common factor, and I hope I said that earlier. I hope I didn't say common denominator by mistake. It's a greatest common factor. Yeah, this should be an F. Greatest common factor. That should be an F. Greatest common factor. So you're revealing the greatest common factor. And notice how it has to be divisible. You're dividing by the same number. You cannot use different numbers like in the numerator and denominator, different numbers. They'd have to be the same number. Okay, so this reduces to 3/5. Okay, that's considered lowest terms. Okay, that's considered a proper fraction. Okay, and for part B, we have negative 170 divided by 102. And we can also reduce that by 2. So half of 170. 170 divided by 2 is 85. So that would be a negative 85. And 102 divided by 2, it's a 51. So we're dividing by 2, see, common divisor, and that gives us 51. Okay. And let's see. Sometimes I use a list of primes. I have this list of primes here. And if I look at 51, see if it's on there. See if 51's not on there. See how it jumps from 47 to 53? That means it's not a prime number. So that means something does go into the 51. Also, 85 is not on here. See how it jumps from 83 to 89? So that means that these are not prime numbers. 85 and 51 are not prime. So that means that something does divide evenly into 85 and 51. So something's divisible, right? When we divide, we end up with a remainder of 0. Not a remainder. You won't get a remainder of 1, 2, 3. So that's, evenly divisible. And so let's see. So we know we can't use 2 again because these are not even numbers. They don't end in 0, 2, 4, 6, or 8. So we cannot use 2. If we try 3, and usually when I try to reduce numbers, I usually exhaust the first 2 rows of prime numbers. Usually, try to reduce a numerator and denominator by a list of prime numbers. But once we exhaust the first 2 rows, if there isn't a common divisor among the first 2 rows, then usually that probably can't be reduced. So if you don't have a sheet like this, I I can check to see if I have um, a sheet like that already available in my notes for the correct class. I have some notes that are saved, but if that's not already saved, I can put up here at the top lists of prime numbers, and I can write the first couple rows up here. So I would try to reduce by 2, and then if not by 3, 5, 7, 11, 13, 17, 19, 23, 29. And then I come around to second row would be 31, 37, 41, 43, 47, 53, 59, 61, 67, and 71. So there's the first 2 rows of our list of primes there, okay? Yeah, so if I just, after I've exhausted 2, then I can test 3. So I'm going to I might have to erase this, but I'm going to just test 3. So I'm thinking this is the greatest common factor. And actually, I take that back. I think I should call it greatest common divisor. Sorry about that. Greatest common divisor. GCD. It'd be okay better to say that. Yeah, what you don't want to say is denominator. You don't want to say greatest common denominator. You say greatest common divisor. Okay? Okay, so let's see if 3 will work. So if I don't get any decimals, then I can use 3. So let's see. So let's try 85 divided by 3. See, that's not good. See how we get a decimal? See that? So then we're not allowed to use 3 then, because it gives us a decimal. Okay, so then if I go down my list, I can try 5 would be the next one to try. Okay, so 85 divided by 5. So that looks good. It's a counting number, 17. But when I do 51 divided by 5, see how I get a decimal? That's not good. So 5 won't work. Okay. And if I just go down my list, I can try 7 now. That would be the next scene. Try 3, try 5, try 7. 85 divided by 7. So that's not good. Get a decimal. So then there's no point in trying to do 51 divided by 7. It has to go into both the numerator and denominator. So after 7, let's try 11. 85 divided by 11. So that's not good. Get a decimal. Okay, let's try 13. 85 divided by 13. Nope. Get a decimal. How about 85 divided by 17? Oh, that looks good. See? So it might be 17 then. So that would be a -5, because remember this had a negative here. Okay, and we think that 17 is the greatest common divisor. So let's try 51 now. 51 divided by 17 looks good. See how we get 3. So see how we're using the same greatest common divisor for the numerator and denominator, and now we're getting 3. Yeah, and that would be fine. Okay, and this is called an improper fraction, because the 5 is a little bit bigger than 3. Okay, so I know it's a -5/3, but this is called improper because 5 is greater than 3. Okay, so if I wanted to make that into a mixed number, what I could do is I could do long division. So I have 5 divided by 3. The top number, the numerator, goes inside the house. So what I mean by inside the house is this long division house, right? The top number, the numerator, goes inside. So 5 divided by 3. And I know it's negative. I'll just put the negative here. Okay, so 3 goes into 5 one time. 3 times 1 is 3. 5 minus 3 is 2r, 2 remainder. And then you're going to record like this. You're going to record clockwise. Okay, so we have a -1, and then see 2, 1 and 2 over 3. Okay, so 1 times 3 is 3, plus 2 is 5. If you do a little check, it would be 1 times 3 plus 2, all over 3. So 1 times 3 is 3 plus 2. So this would be 3 plus 2 over 3 should be 5 over 3. Okay, which pretty much is similar to this, right? Except we just left off the negative on purpose. We have the negative there, but just double checking 5/3 becomes that 1 and 2/3. Okay, and the negative is out here because of this. So that's a mixed number. Okay, so first we use 2 and then we use 17. Now that we've done 2 and 17, we've used 2 and 17. Now I can say, oh, if I had done, see, 17 divided by 2, if I had done 34, if I had done third, that would have been the greatest common divisor. So in other words, these then, let me see, these are actually just common. These are common divisors, not the greatest. These are just common. These are common divisors. So these are common divisors. Okay. The 2 and the 17. But when I do 2 times 17, which is 34, 34 is the greatest common divisor. Greatest common divisor. So if I do 170 divided by 34, see how that gives me the 5? And then 102 divided by 34 gives me the 3. See that? So can work with that as well. But this, for this one, this was the greatest common divisor too. These are common divisors. And the greatest common divisor would be the product. 2 times 17 is 34. Okay, so for part C, I want to reduce by 2's. Half of 20 is 10. Half of 24 is 12. Okay, so I can show you that here. 20 divided by 2 and 24 divided by 2. So I get 10 over 12. Okay, then I can reduce again by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. So I get 5, 6. Okay, so 10 divided by 2 is 5. 12 divided by 2 is 6. Okay, and that cannot be reduced anymore. This is lowest terms. So now looking back, these are common divisors, but now looking back, see how 2 and 2, see 2 times 2 is 4. So that means that I could have reduced that by 4. Greatest common divisor would have been 4. So if I show you that here, show you divided by 4, this is the greatest common divisor. Okay, where these are just, this is common divisor. Common divisor. This is the greatest common divisor because 20 divided by 4 is 5, and 24 divided by 4 is 6. Okay, we got that. Okay, now on the bottom, they also say simplify the fraction, write the answer as a fraction or a whole number. Okay, right. So with 75 over 25, it looks like because if we use our divisibility rules, because these end in 5, if these end in 5, then 5 should be like a divisibility rule. 5 should be a number that can divide evenly into 75 and 25. And that's because these end in 5. 75 ends in 5, 25 ends in 5. So if it ends in 5, in 5, then 5 is a CD, a common divisor. So if I do 75 divided by 5, so that's 15. And if I do 25 divided by 5, it looks like it's 5. See that? So if I write that here, let's see. 75 divided by 5 was 15. 25 divided by 5 was 5. Okay. Now this can be simplified. And maybe we didn't see it over here, 75 divided by 25. Maybe we didn't see that here, that 25 will go into 75 evenly, but here 15 divided by 5 is easier to see. That looks like that'll be 3. If I just show here 15 divided by 5, that gives me 3. Yeah. Okay. So no need to write 3 over 1 because 3 over 1 simplifies to just 3. So when you're simplifying, you just write it up as 3. Okay. And then for this one, I divide by 2. Like what's half of 12? 6. What's half of 60? 3. So these numbers are easily divisible by 2. They end in, like they said, a 2 or 0. They're even numbers. And so I just did half of 12. 12 divided by 2. Half of 60. 60 divided by 2. That gives me 6 over 30. But then that can be reduced again by 2. Half of 6 is 3. Half of 30 is 15. So 6 divided by 2 is 3. And 30 divided by 2 is 15. Okay, and this can be reduced, looks like one more time, by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Okay, that's the lowest terms. So I can show you that here in the calculator. 3 divided by 3 is 1. 15 divided by 3 is 5. Okay. Okay, I think there's one last page to show you. Simplify each fraction to lowest terms by first reducing by 10, 100, or 1,000. Write the answers as a fraction. Okay, let's see. So what we can do is, like a little shortcut is you are allowed to cancel out n zeros. So n zeros do cancel out. You are allowed to do that. N zeros. N zeros cancel out. Okay, so you say your teacher knocked out this 0. It's a 1-for-1 ratio, every one on top, one on the bottom. And now this is just left with 17 over 3. Okay. So when they cross that out, what that means is that means they just divide it by 10. So if I do 170 divided by 10, okay, that gives us 17. And then 30 divided by 10 gives us 3. Okay. So again, this isn't proper. Okay, and then I can do long division. 17 divided by 3. 17 divided by 3. So 3 goes into 17 5 times. 5 times 3 is 15, and you get a remainder of 1. So then this gets recorded like this, clockwise. So record clockwise, record clockwise. So this would be 5 and 1/3, 5 and 1/3. Okay. 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 And then B. So look at this last problem. Again, if I cross off for every n0, for every n0 in the numerator, I can cross out the n0 denominator. And so we can say we're starting off with 25 over 750. Okay, so that's allowed. So what they've done is when they've crossed out 2 zeros, it's like they've divided by 2,500, I believe. If I do 2,500 divided by 100, yeah, it gives me 25. See, 75,000 divided by 100. 750, yeah. So when you're knocking out these n zeros and zero on tops and the bottom, another n zero right at the top and the bottom, and you see how we knocked out 2 zeros. What that means is that we knocked out 100. Okay. Okay. And then I think this can be reduced again. Okay. So you can try 25, or you could try 5. Okay. So if we try let's see, 25 divided by 750. If I try and divide that, you're safe with 5 because you want to divide by 5 if you have numbers that end in a 5 or a 0, and we do. So you actually could use 5 here, but also 25, if you see how we can use 25 also. That's the greatest common divisor. Let's see if that works. 25 divided by 25 is 1. 750 divided by 25 is 30. And that would be lowest terms. 1 over 30, that would be lowest terms. Okay. So hopefully that helps you with reducing of fractions. Another method to show you, just to show you, is another method would be division. Let's see, dividing by prime, so prime factorization. So if I had that 170 over 30 like we have here, if I wanted to reduce, and I want to write using I want to reduce, I want to express, let's see, express Numerator, express numerator and denominator as prime factorizations. We could also do that. So I would have to do a factor tree like for 170, break it down. Like what times what is 170? So like 17 times 10 is 170. 17 is a prime number, so I won't be able to break that down. See how 17 is right here? It's a prime number. So I cannot break that down further. That's prime, circle it. But 10 is 2 times 5. This is 2 times 5 times 17. 2 times 5 times 17 is 170. And of course you can check it. 2 times 5 times 17. Yep, it's 170. So you should always check that. And see, these are all prime. See, these are no evens, just prime numbers. Okay, and the same thing if I break down 30. 30 is like 3 times 10 is 30. 3 is prime. 10 is 2 times 5 is 10. So it looks like 30 is 2 times 3 times 5. And if I want to check that, 2 times 3 times 5. Yep, it's 30. Okay. So then after we write the prime factorizations, then what we want to do is we want to cancel out exact factors. And it's like a 1-for-1 ratio. So you see how these 2's would cancel out here. And see how those 5 would cancel out. So then what are we left with? We're left with just 17 in the numerator, and in the denominator we have 3. And see, so you see this is what we had over here. See this problems, this is improper. We had that. We just did it a different way. We just used prime factorizations. Okay. And then we canceled out exact factors. Okay. And this is improper. And of course, if you wanted to make it a mixed number, you could. You would just, this is your, you just make it, do long division, 17 divided by 3, and record in your checklist. Okay. All right. Let's see, if you want me to go back and on the first page to show that method, prime factorizations, we could try that on B. So 12 over 60. And we're using prime factorizations. So 12 is 2 times 6. 2 is prime. 6 is 2 times 3. So 12 is 2 times 2 times 3. If you check that, 2 times 2 is 4, and 4 times 3 is 12. And 60 is 2 times 30. 2 is prime. 30 can be broken down by 2 again. 2 times 15. Okay, and now 2 is already prime. But then 15 can be broken down as 3 times 5. these are prime. So it looks like we have a 2 2s, a 3, and a 5. 2 2s, a 3, and a 5. And if I try to cancel out like exact factors, like factors, see, one, it's a 1-for-1 ratio, one on top, one on the bottom. And so now we're left with just, it looks like a whole bunch of ones. So this is left with a 1 over 5. So it looks like that's 1/5 then. Okay, so hope that other method helps. There's a couple ideas there for reducing. Okay, so work on your connect math then, okay? Your co-rec and get that done. Take care.